Hi everyone, and welcome to Nordic Serverless online meetup. I'm Gunnar Grosch, and today we have two sessions on our agenda. We have Darko Mesaros, developer advocate from AWS. He will talk to us about AWS CDK. And if you ever watch Darko on one of his Twitch streams, you know that we're in for quite a lot of demos. But first up, we have Marcia Villalba. She's a senior developer advocate for AWS. And she will show us how to build event-driven serverless applications using Amazon EventBridge. But before that, if you have any questions during the sessions, feel free to ask them in the Serverless Forum Slack. Both Marcia and Darko will have a Q&A section in the end, so just keep your questions coming there. If you're not already a member, you can join by going to nordicserverless.io/Slack and just join the channel Nordic Serverless. But now, without further ado, I'll leave it to Marcia for her session on Amazon EventBridge.
Happy to be here tonight or today, wherever you are watching this from. I will be giving a session on building event-driven applications with Amazon EventBridge. I think this is a fun session because I like this service a lot. So I think if you have not used it, it's quite a new service, launched less than a year ago. So if you have not used it, I hope it inspires you to try it out. First, I want to introduce me. I'm Marcia Villalba. I'm a developer advocate. I'm based in the Nordics, so this Nordic Serverless is kind of my area of reign. No, joking, but I work a lot with Gunnar, so I'm very happy that he invited me here. I've been coding all my life, and for the last 7 months, I've been working in AWS as a developer advocate. I'm the host of a YouTube channel called Fubar, where I post videos now 2 or 3 times a week because I'm at home and I have a lot of time to make content about serverless and cloud computing. And most of my videos are super hands-on with Git repo that you can follow along and learn all kind of things. By the way, yesterday I finished my session on building analytics pipelines, serverless analytics pipelines, and it's like, I don't know, like 120 minutes long, 5 series of videos, so go ahead and check it out. But without further ado, let's start with the talk of today, that is event-driven applications. And I want to use the example for thinking about event-driven applications of something that we have been using a lot today. If you're at home, maybe in your country, restaurants are closed, but they are delivering food. I live in Finland, and delivery is the only way that we get to eat out. Well, we don't get to eat out, but we get not to cook or wash dishes. So I've been using a lot these tools like Deliveroo, Uber Eats, Foodora, whatever is in your country. And I think they're a great example of an event-driven application. You have this kind of application that is aggregating orders and like customers and restaurants. And then when you make an order, the event goes to the chef. The chef is making the food in the restaurant, cooking whatever you ask for. Then we have a delivery guy or girl sending in a bike or in a car, whatever, getting you the dish that you order. So you can enjoy some no washing dishes meal. And that's great. And if we think about it, this is a very small simplification of just part of this architecture, but I imagine it works something like this. You have the person ordering that hits this order aggregator service or whatever you want to call it, and then it's connected to multiple restaurants. And all these restaurants are taking the orders. And we have multiple ways for this order aggregator service to connect to these restaurants. One way is that the restaurant will just poke the aggregator service every, 5 minutes, 1 hour, whatever is optimal, to ask if you have an order. And this is something that I don't think is practical first, because you might add a lot of calls to the aggregator service that might return no response, like there is no order for a restaurant. Or maybe if you don't do it frequently enough, then the customers are waiting for 20 minutes without getting any response from the restaurant. Also, if there is multiple aggregator services that are, as they are in the cities, that you have, I don't know, as I said, Deliveroo, Uber Eats, Foodora, and whatever, you might need to connect this restaurant to multiple different order aggregators. Another way is to do it the other way around, that the aggregator service is the one sending a message to the restaurant. But here we will have the aggregator service needs to know all the restaurants and needs to connect to all the restaurants, and they need to build an interface that works with all the restaurants. And then if there is multiple aggregator services, we end up with a mess of connections going to one side and to the other that is very hard to maintain and to manage. And a simpler way is just to send an event in the format and the way that the restaurant aggregator service decide to, but it's an event that is totally loosely coupled one from the other. The two of them don't need to have an API or an interface to communicate specifically for receiving this event. So we will see a solution for this problem in just a second. I will show you a demo exactly on this. But for now, let's look a little bit also on the benefits of implementing event-driven applications in your organizations. You don't need to have two separate systems residing in two different organizations. You can do it for your applications that are inside your own company. So if you work with different teams and, for example, you use this architecture pattern, then you will be able to scale and fail the components independently. So usually there is these parts of the applications that tend to be the ones that receive 80% of the traffic, the biggest load, and you want to scale that up. And if you have an event-driven application, you can do it pretty easily without needing to scale the whole system. As well, if something fails, usually when you have an event-driven application, as not all the pieces are highly connected, then things can fail in a more independent way and you don't have a waterfall of mess of things that you didn't imagine that they were connected to your application. Another benefit is that as everything is very independent, you can deploy parts of your application without really worrying about what is happening in the rest of your application, because things are not connected with APIs. Then you can just deploy your service and send events while you keep the format of the events. In general, it's okay. And if you make some changes, then if they're backwards compatible, it should be fine. So then in that way, you can deploy multiple times a day without caring what the other parts of your organization are doing. Everything can go more agile. One benefit that I like a lot is that because everything is event-driven in this architecture, then you will have all the events and you can store them. And then if you ever need to audit what happened in your application, you have all the register of what happened in your application. If you lose one data source, you can even replay those events and have the data source recomposed, for example. And if you use event-driven architectures, it's way easier to use serverless components like Lambda and things like that. So that will help you to cut costs. So the first thing you need to do when you are doing event-driven applications is pick an event router. And you're wondering why I need an event router. You have the producer, you have the consumer. We can imagine the case of the aggregator and the restaurants, and they can connect through a message. That's what we have been doing forever. But what happens when we have multiple producers and multiple consumers? And that was my idea of trying to explain when you have multiple aggregator services and multiple producers, consumers, restaurants in this case, it can turn to something like this. And this is very hard to maintain. You have multiple connections and you need to do a lot of routing in the producers to get to the right consumer. You need to add a lot of logic in the producers, and that's very hard to maintain. Also, if you add a new consumer, you need to register it, so everything needs to be somehow impacting everything else. So when you add a new consumer, you will need to change the code in as many producers as need to send message to that, and that's not very efficient. That's very highly coupled, and you don't want to do that. Instead, you want to add something like this pink box here. I think it's an hexagon. And this pink box will allow you to decouple the producers from the consumers. And this is pretty neat because now when a new consumer joins, it's just joined to the event router. It's one place where you need to add that consumer. And when a new producer joins, it just needs to send the events to that event router. There is not much work to be done. But then you might be thinking, but that pink box, hexagonus, sounds like kind of bottleneck for my application. It's just one component there that everything is going forward through it. And I would say, yes, it is. But that's when we think about in the traditional world, when we have our data centers and we will build this as a service, it's very hard to scale a service like this because you have all this traffic going back and forth. But in the serverless world, in the distributed world, in the cloud computing world, this is not one single point of failure. This is just a service. It draws as a box in the architectural diagram, but it's a fully managed service by the cloud that you don't need to worry, and the cloud will take care that is distributed, that is scalable, that is resilient, that is distributed multiple availability zones, and all those things that you want from a component. So it's not a scary thing anymore. So in July 2019, AWS launched this service called EventBridge that was designed to solve this problem. It's a fully managed service. You pay as you go, and it has integrations with so many AWS services, with SaaS providers, and you can also integrate it with your custom applications. And then in the other side, it can send events to, I think, 17 target services, but this number might change because AWS launches things all the time, so you never know what is a real number. It can be more. But let's say that is 17. So how this works, it's pretty straightforward. You have the event source, whatever is sending the events. It can be an AWS service like an S3 bucket, a new file has been uploaded to a bucket. Or it can be a SaaS application like Datadog, Zendesk, whatever, Mongo Atlas, there is many, Auth0. And for example, if you have a new Zendesk ticket, it can also send an event. Or if somebody has logged in using their Auth0 credentials, they can get an event. Or if something happened in your MongoDB Atlas table, it can send an event to EventBridge. And then you have your custom applications, whatever you imagine that you want to send events through. So this is pretty powerful when you have so many options as event sources. Then in the other side, we have the targets. And the targets are these 17 services from AWS that can receive the events. We have, I put here 4, but there could be others. I put Lambda because I think Lambda is an excellent example of event-driven applications. When it receives an event, it triggers and it does something. Then we have Kinesis Firehose that it can be collecting the events and storing it in an S3. We can have step functions that get triggered when a new event arrives. So if you have, for example, a Zendesk ticket, it sends an event like, for example, the ticket has a very bad rating. So you can start a workflow to try to figure out what happened with that ticket and do some follow-up. I don't know, just saying an example. And then you can connect it to SQS or SNS or whatever you imagine. There's multiple services that can be handled there. And then in the middle, we have the EventBridge Event Pass. This is the pink box that we saw in the previous diagram. And in here, we will have rules. We will need to find the rules. And the rules are the ones that are doing the magic. The ones that are saying, okay, this event with this particular information needs to go to this target. So you need to build these rules, and the rules can be as generic as all the events for S3 goes to Lambda, or they can be as precise as, well, the events that are coming from this custom application that has this and this information in the payload will go to step functions. So it depends. It's very, the rules, I will show you some examples, and then I will give you some resources where you can see the powerful things that you can build with these rules. So the rules are connected to the target. So an event comes in from the event source, and then it will go to all the rules. It will get analyzed by all the rules. Some of the rules will turn pink. That means that the rule is matching the event. And then what happens is the event will be sent to all the targets. It's pretty straightforward. There's other event routers inside AWS, and you might be familiar with them because EventBridge is not that old, so you might be using them, like SNS, MQ, Kinesis Data Stream, Managed Kafka, that's quite new. But there's also some event routers that you create, like Kafka in an EC2. That's a typical thing that a lot of customers do. And I cannot tell you which one is the right solution for your problem. But I think it's important to have in mind that EventBridge was designed for this. This is the main purpose of EventBridge. But then there's also other dimensions that you might need to have in consideration when when choosing your router. For example, how much operational responsibility there is. EventBridge is a fully managed service, and if you have something like a Kafka and an EC2, you have way more things to do to keep that service alive, to scale it. But then, in the other hand, you have a lot of power to control that service, to make optimizations and configurations that match your specific needs. So it's a trade-off always when you choose a managed service. You are losing a little bit of control for giving up some cost of ownership and don't have to deal with a lot of the pain. And in, I would say, 80% of the cases, you can go with EventBridge quite safely. Another reason why you might not choose EventBridge is that you need order events. EventBridge doesn't have order events. It will receive the events in any order, and if your application cannot take events that are coming in any order, then maybe EventBridge is not the right solution for you. But again, if you're building a greenfield application, I will really ask you to reconsider the need for order events. If you need order events, you're adding a lot of fragility to your application. And nowadays, there is way many papers and documents and architectural patterns on how to handle events that are coming not in order. So you might want to reconsider that and not need that feature from the routing. But maybe you're working with a legacy application and you don't have any other option because you are not wanting to get your hands inside that legacy application that nobody wants to touch. You just want to send events and that's what you want to do. And in that case, I understand that you need the well-ordered events. So really think about it if you need it. One cool thing from EventBridge is the types of integration it has. I already talked about the integrations between the event producers, the AWS services, your custom applications, and the SaaS providers. I already talked about also the integrations between the target services that are doing the business process for that event. But then there is a couple more integrations that are pretty neat. We have a really good integration with CloudWatch Logs, where all the events can be stored, so you can create this audit record of your events. So there you will see all the events that have gone through your event bus or the ones that you want it to be stored, and you can have an audit on your application. And then we have this other option, for example, to send it to Kinesis Data Firehose, store it in a S3 bucket, and then use Athena to run ad hoc queries. So if you're thinking, oh, why this customer, blah, 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 happened this and that, then you can go to Athena, ask a question with that customer ID, and you might find the logs for that have been handling that customer order or that particular piece of information that you're missing. And that's extremely powerful that you get kind of for free when using EventBridge. So the next question you might be wondering is how many event buses, or maybe you have not been wondering because you have not got that far, but I can tell you, you can have multiple event buses. There is 3 types of event buses. You have the default one, that is where all the AWS services will send the message. We have the customs, is where in general applications are sending their messages, and you can create as many as you want. I don't know, I'm sure it's not as many as you want, but you can create many. And then we have the partner, that is where the different SaaS providers will be sending their messages. You can also send messages from your custom applications in the default event bus, so you don't need to create a new one. And in this case, you can mix AWS services and applications. And this is a use case I do most of the time because my applications don't require me to have multiple event buses, and this makes my life easier. Then you can go to the other extreme where everything has their own event bus. Every application or every producer has their own specific event bus. And that's totally fine. Again, I cannot tell you what is the right answer, but I think you need to find the balance on the amount of buses that you have so you don't end up in something like this. This is a really bad practice. When you have routing in the producer, you want to avoid the routing in the producer at all costs. The idea of adding the event bus is to reduce the coupling between the producer and the consumer. And if you have multiple buses and the producer needs to decide to which one send the event, then you're not achieving that goal. So please don't do this. This is a bad pattern. Try to avoid it. One thing you can do if you want to have multiple buses because you need so, one thing to think about is that you can align these buses with your domains or with your microservices or things like that. So then the data that is flying or moving inside these buses is can go together, doesn't have any security restrictions that you cannot share between maybe one application and the other. So these two buses are isolated and they're okay, and the consumers, the producers don't need to route into any particular bus. They will have one bus where they will send the information, and then the bus will be deciding to which target to send it. One thing that I like a lot is that when you are provisioning the event bus and the rules of this bus can be provisioned in different stacks. And you might be wondering why I care. You care a lot. So in this example, we have 3 different, in this case, CloudFormation stacks. They can be anything. 3 different stacks. The first one that we see called shared services is the one we have all the shared services for the consumers. We have the producer, maybe, we have the event bus, we have the logs, blah, blah, blah. And then we have consumer A and consumer B as 2 different stacks. And these ones will define the rule. And the cool thing, because the rule is so closely and tied to the consumer, that you want to have it there, because in general, when you add a new consumer, you will need to add a new rule so the events can get targeted to that particular consumer. So I think it's a really neat thing when you have the rule defining the same stack as the whole business logic of the consumer. So then when you add a new consumer, you don't need to touch at all the shared service stack. You just deploy a new stack with consumer C, with its rules and its business logic. You can also do cross-account events, so that's also pretty neat. You can have the producer in one account, the consumers in multiple accounts, and you can send information around in events. For that, you will need to put an event bus in front of the consumer in the different accounts. And in here, you notice that you will need to do some routing in the producer, and you don't want to do that. Because, as I said a few minutes ago, that's a very bad practice. So in order to avoid that, you just add a local event bus there, and then the producer will send the events there, and then the local event bus will know to which a local event bus in the other account send the messages. And in this way, you have cross-account events that works very well, and they are totally following the rules of loosely coupled architectures. One thing is that we want to be very conscious about is how we structure the events. We have kind of 2 ways. I imagine there are millions, but these are the 2 main ways. One is to have events that are very concrete, that says very small thing, but the things that are needed in order, if somebody wants to fetch that information, they can go to a service and fetch it. For example, the order was created, blah, blah, blah. Very small, very concrete, but if somebody wants the information for the order, they can go to the order service and get that particular order. And then in the other hand, we have the full state descriptions when you put that same information than in the short event, and then you start putting more information, like what happened with that order, when it was created, what was the amount, where were the products. You have a very long description. If you do the short version, that's good. In a lot of cases works very well, but be aware that if you have a lot of services that might come back to you and ask the details for the order, then they might bomb you with a lot of requests that you might not need. So maybe then is when you need to consider the full state descriptions, that you send all the information to in the event. But in that case, remember that the information that might be sent in that full state descriptions might be getting old, and the service that receives it might need to do an update or might not know that information is old. So it's a trade-off that you need to balance when you are designing what kind of events you want. And I will tell you, in some services or even in some messaging parts of your applications, you want to send the shorter events, and in others, you might want to sell the full state description. It's not like one or the other. Now let's look at the details of an event, what you will see when you're sending an event and how an EventBridge event looks. So it looks like this. It's a JSON. and it has two parts, the envelope metadata and the payload. The envelope metadata is more or less the same to all the events, and the payload is something that you will be able to, if you're building a custom application, write whatever you want there. It needs to be a valid JSON. In the envelope metadata, we will see some attributes that are your account ID, the ID of this event, the region, and blah, blah, blah. Then we will see a timestamp. We will see the source that created this event, the service that created this event. Then, for example, it can be S3. Then we can see a detail type, and here it can put object. If you have a custom application, you can tune this to source and detail type to whatever you want. And then you have the resources that are identifiers impacted by the events. I never use this. And then we have the detail, that is the payload that you will write if you're creating a custom application, or the different SaaS providers might provide different information there. And this is a valid JSON object. So the last thing before we go to the demo, and I show you this, how it works with a SAM application, is to think how we can manage these events. We will have EventBridge sitting in the middle of an organization that is sending events one another, that is very loosely coupled, and how we know what is in the events. So reInvent last year, this feature was launched, the schema registry and the discovery. And this schema registry is a place where you can see all the definitions for all the AWS events, and then for all the events that you discover during your time. So first, the AWS events, before having the schema registry, you needed to guess a lot of things in order to build these rules. It was a lot of guessing and reading documentation, and it was hard. Now with the schema registry, I will show it to you in a moment, you can see all the information of the event, and you can create rules that match those events pretty easily. Then for the schemas that you discover in the way, that means that you need to enable the discovery in your event bus. There is a button, I will show it to you in a second, that you enable the discovery, and then all the events that go through your event bus will be registered in your schema registry. So in general, these events are the custom applications or the SaaS providers events that are coming through your application. And when they're inside your registry, then you know how to handle the event, how to create rules. And if you want, you can also download integrations for different languages like Java, Python, or TypeScript. You can get the code bindings, and then you can even manipulate them in code. So it's pretty nice. For the schema registry is free, you don't need to pay anything, and the schema discovery is a little bit expensive, but I think the intended use case, and I think that's the use case I've been giving it, and most of the people I know give, is for development. So you enable it a little bit, you see what events are coming, you start figuring out the schemas, and then you turn it off. It's not something that is on all the time. But I'm pretty sure that some customers eventually will find the option that they need to have it all the time to some kind of crazy thing. So if you're one of those guys, girls, let me know. I'm always interested to know how people are using the services in creative ways. So now let's go to the demo, because I want to show you all this, and I think it's so much easier if I show it to you. So this is our architecture. It's very similar to the other drawing when we have the multiple stacks, because it's inspired that we will have an order manager, like the aggregator for orders, like Uber Eats or Foodora or Deliveroo or whatever you have in your country, that collects all the orders that customers made. I forgot to put the API gateway there, but API gateway is calling that first Lambda. That Lambda will put messages inside the event bus. And then, depending on the type of message that was put in there, the right rule will get triggered. So basically, these rules will be analyzing the restaurant name that is inside the payload of the event. If the restaurant name is Pizza Hut, it will send it to that particular Lambda function. If it's Thailand, it will go to this other Lambda function. But if it's not any of this, then it will go to another Lambda function in the order manager stack that it will say, hey, sorry. So I will switch now to my Visual Studio Code. I hope you can see it. And I will show you a little bit the code. This is available in GitHub. I will leave you the link, so don't panic. So you can see I have three here different projects. These are all three different SAM projects. So the first one is the order manager, and we can check the template. It's a very simple template. We have one API gateway called orders API. We have one function called put order function, and then another function that is the one that gets triggered when there is not a valid restaurant name in the API call. But first, let's look at the function that is putting the messages in EventBridge. It's a simple function built on SAM, where we have the only kind of weird things is that we are giving permissions to put messages into EventBridge. The rest is the same. We have here the API gateway that triggers this Lambda function, and then we can check the handler and see how the messages are put. I code it very nasty, so it's not doing any magic here. It's basically grabbing the order details from the body of the HTTP request and then sending the event to the EventBridge. For that, I'm using the AWS SDK. So the first thing we want to do is to build a payload of our event. And in the SDK, it's called the detail. And I will build it like this. Basically, whatever comes in the request, I will put it in the detail. The restaurant name, the order, the amount, whoever ordered it. And then I need to build the envelope. So some of the things like the timestamp, the account, all these managed parameters will come automatically in the event, so I don't need to worry. But some of them I need to type it myself, like the data, the source, that is the service that originates this message. As this is a custom application, I need to write a name for it. So I will put custom order manager, just put something. And then the detail type, I need to put like a new order was created. I just very verbose and put order. So with these three things, I now have ready my event. I could put multiple events. As you see, these params takes an array. So if I want to put multiple events, I only put in one. And then I just put it in the EventBridge service in the SDK here in the module EventBridge, and that will be sent to EventBridge. This works very fast. So I will show you in a second how everything works. Then we have the two restaurants here, Pizza Hut and Thailand. We can have as many as we want, but they are more or less the same. But I wanted to create two because I implemented the way that they respond to the rule and how the rule is defined in two different ways. Pizza Hut has the more traditional approach that is using cloud formation. So the first thing we define is the function. And then we have the rule defined as a CloudFormation structure, and also the permission for that rule to invoke the Lambda. This is the typical way that you will do it with CloudFormation. The function doesn't have an event trigger because it's a rule that will trigger it. And then in the rule, you will need to have this event pattern, and this is the rule matching. So here you can see that we are matching against the source. The source needs to be custom.orderManager. If the source is not that, then it will not trigger this rule. If the detail type is not order, then it will not trigger this rule. And then the restaurant name needs to be Pizza Hut. So these three things needs to match in order for this to happen. And then this rule will trigger this Pizza Hut function. And finally, we need the permissions. We need the permission for this rule to invoke that Lambda function. Then in the restaurant Thailand, I have implemented exactly the same, but in a different way, taking advantage of SAM. So you can already see that I only have one thing here that is a SAM function, and it has an event trigger. So until here is exactly the same as the Pizza Hut, but then it has this event trigger, and everything that was in the rule and the rule permissions, it's just in these lines of code. Basically, most of the lines are spent in defining the pattern for pattern matching. So you have the trigger, you put the CloudWatch events, because at the end of the day, EventBridge is a CloudWatch event hidden somewhere. Before, we used to use a lot of CloudWatch events to do the same things. Now there is a service on top of it. And then we have the pattern matching that is exactly the same as in Pizza Hut. The only difference is that we have the restaurant name Thailand. And then finally, the other Lambda function that we had was the one that is not a valid restaurant. And I define it in the same way as the Thailand, but it's in the order manager stack. And in here you can see that the pattern, it has the same. It needs to be the order manager, need to order, but then it has this anything but. And here I'm just listing all the restaurants. So whenever it's anything but these two, and it's part of the custom order manager, and the order, it triggers this Lambda function. So if you want to know more, I will skip this because I already showed it to you. If you want to know more about the routing and the rules and the pattern matching, I recommend you to read this document. This documentation is really good on all the possibilities you have when working with these rules. I think it's super important to take a look and learn because they are very powerful. And finally, I will show you this working. So I will first go to my AWS console and go to EventBridge. And here we can go to see the event buses. In this case, I only have the default one is here. And you can see here that is the start discovery. This will start discovering the events that go through my bus. If I enable it, the discovery started, and whatever event is coming through my bus, it's going to get written in the registry. But for now, I'm sorry, I don't have any new events. I have discovered them all. In my registry, I can see here that all the discovery schema registers, this is the one that I've been going to be sending now. So it's already discovered, but it's here where it will all the events that are discovered will appear. So if we open one, you can start taking a look at how the event looks and what are the different parts of the events. It looks very ugly, but after a while you get used to it and it's not that bad. And it's really nice to be able to see all this information here, and more for the AWS schemas that you can have them as well here. And here you can find like S3, for example, and you can get all the different events for, I don't know, whatever you need that is sending events. So in the event bus, we will have rules. And here are the 3 rules that I just deployed. I deployed this application with serverless with SAM, so it deployed everything for me. I have the 3 rules, the not valid restaurant, the Pizza Hut, and the Thailand. I can show you one, how it looks. Here you can see the metrics for the rules if you're interested. And then you can see the event pattern here that needs to match this particular rule. And then the target function. So good. Now let's do a short demo and how this runs, and we are ready to go to the QA. So I will open the Pizza Hut Lambda function. Let's go to the logs. So this updates realistically fast enough. And I will go to Postman. I have already prepared my HTTP request to this endpoint with this body. This is a restaurant name, Pizza Hut, and then random stuff that I don't care. Let's send it. And now we got the 200, and this triggered the Lambda. The Lambda put the event in the event bus, and now basically it already executed the Pizza Hut Lambda. So it's super fast, just the logs are not fast enough. But now they're already here. And we can see that Pizza Hut has received an order, and I just printed the event that is coming through the Lambda. And you can see that there is the managed attributes here, the ID, the account, and the region, the time. And then we have this source, and then we have the detail type and the resources, and then the payload. So everything I show you in the event is here. If you want to get started trying my demo out, here is the link. I think I can give it to Gunnar so he can share with you. This is the demo. And I think it's also in the slides, so you can try it out. Let's see. Yeah, here it is in big one. And when I share the slides with you, then you are getting the link if you want to try it out. And if you have any questions, I'm happy to take them. And I can answer here. I think we have some time. Let's see. Where is my Slack?
Hey, Marcia, I'm with you now.
Oh, good. I will close then my screen so it's nicer.
Yeah, thank you very much for a very good session on Amazon EventBridge. So we have a few questions in Slack. Nice. The first one is about concurrency. A user having issues with concurrency in event-driven architectures. Is that something you've seen in regards to serverless, or do you think that's mainly a more traditional architecture? Or
Well, concurrency should not be a problem in event-driven architectures in general. I don't know what exactly he meant by concurrency, but in general, the events should come. As I said, the order should not be a big deal. You should not care about the order of your events, and if multiple events are running at the same time, it should be fine because serverless applications tend to scale. So unless you have, I don't know, something very specific, maybe he can explain a little bit more about what he meant by concurrency and what is exactly his problem.
yeah,
But
you can ask follow-up questions in the Slack, and
yeah,
perhaps you can see
exactly.
that.
I'm hanging out here in the Slack for all the sessions, so I'm happy to deep dive a little bit more on what he meant by concurrency in this particular topic.
And the next question was around where Amazon EventBridge fits in. There are quite a lot of offerings when it comes to services for queuing and for notifications and so on.
Yeah, that's what I was trying to explain in the moment that how you pick a router. EventBridge is designed for architecting event-driven applications. So it's the main reason why they created is fully managed service, and that you don't get, for example, with even managed Kafka. It's not 100% fully managed, and other services like Firehose, you still have some work to do, and it depends on what you're building. For example, if you are building an event ingestor because you're sending, I don't know, IoT messages, maybe EventBridge is not the right solution because you are not building an event-driven application. You're just ingesting events. So then maybe you need to use Firehose or Kinesis or something that is designed for that. So it's a matter of looking at what exactly are your needs. And again, if you might need ordering, then maybe EventBridge is not the right solution. Then in some point, EventBridge gets a little bit too expensive. So then you need to think, well, I want to use some other service that is more cost efficient? But maybe then you're not having an event-driven application, but you're having some ingestion on events that you're managing some kind of things that, I don't know, IoT is a great example because people think that by putting IoT devices and sending events, they're having an event-driven architecture, but in some cases, they're just ingesting data and then they need to process it. And it's not that they are just sending messages and triggering workflows with each independent messages has some impact. When in the case of event-driven architectures, every message is doing something. It's, in general, it's not going to be stored. It triggers some business logic or some workflow. So EventBridge fits very well in that use case. And if you are doing internally inside AWS, the messages are free, so it's kind of nice. I use it a lot, and I think also Jeremy Daly does it like that, that when he builds serverless applications, he, instead of using queues or SNS, I don't do it like that. Since EventBridge was launched, I just put EventBridge everywhere because it's so much easier to use. And for example, now with the Lambda destinations, you don't even need to use the AWS SDK at all. You can define in your infrastructure when you are coding your SOM template for that particular Lambda. If the Lambda succeeds, send a message to EventBridge, and you don't even need to load the AWS SDK and handle that. And if the Lambda fails, then it goes to it writes another event in EventBridge with a different event. So you can do quite a lot of things connecting different Lambda together, for example, that's quite a normal use case, using EventBridge as a buffer between the Lambdas. So I think it's a great example for event-driven architectures with almost no pain.
Yeah, really good. I think there are some more questions, but perhaps you can answer them in Slack. And keep your questions coming for Marcia.
Yeah.
And with that, thank you very much, Marcia, once again.
Thank you for inviting me.
And I'm going to leave it over to Darko now. So thanks, Marcia. And Darko, time for you.
Hello, hi. I think I need to just share my different screen. Just give me a second, Gunnar. I need to share a different window, and it's this one, because I promise I have some slides here as well. Cool. Are we ready? Yeah? Awesome. So Welcome and hello to my talk about AWS Cloud Development Kit. And thank you, first of all, thank you all from the Nordic Serverless community for inviting me on this one. And I really hope that I could see you all in person, but remote is also cool. So today my talk is gonna focus around Cloud Development Kit, or CDK. And I promise I don't have a lot of slides. I have a total of 19 slides, including 5 like intro and outro slides. So I'll keep it at a minimum, and you will be seeing my either browser or terminal quite a lot. So I would like to keep this as a very relaxed presentation. I have my glass of water or gin. You never know, right? It's clear, right? So and I'm going to be talking through all of this with you today. So let's kick it off. First of all, who am I and why should you care? I am this person in this little box on the left, I guess. My name is Darko Mesaros. I am a developer advocate, same as my colleague Marcia, and I really enjoyed her talk. I am based in Berlin, Germany, but I originally come from Serbia. And one of the interesting facts about myself is that I've changed 7 countries in like 7 years. So moved from Serbia to Czech Republic to Malta to Ireland, and now living in Berlin, Germany. You can follow me on all of these social medias. I do a lot of Twitch streaming like twice a week. So if you're interested in things like such, do let me know. So let's start at somewhere, right? So let's start at the beginning, right? When you started provisioning servers, right, way back when, I used to work for companies that used to do this as well. We would provision servers as physical boxes, right? You have a person that basically goes to a data center and racks and stacks stuff. Fun times, right? Everybody enjoys all of that. But things have changed as we move to the cloud. So, and what is this thing that has changed? So instead of thinking about our infrastructure as these bunch of boxes, which somebody has to plug in and set up and do cooling and all, still somebody has to do it. Even in your serverless world, there are servers, right? But somebody has to set them up. So this doesn't exist anymore to that extent. So when we talk about provisioning infrastructure, we talk about provisioning infrastructure as code. So all of that racking and stacking has turned into something lovely like this, right? So this is a piece of actually CDK code written in TypeScript. And I'll show the same thing a bit later on, right? So why would you use infrastructure as code? What's the deal, right? Isn't it just easier to go to a web console and click a bunch of buttons and get yourself a Lambda script? Well, there's other things when it comes to infrastructure as code, some other goals that we like to achieve. First of all, we like to achieve like this infrastructure that is repeatable, and the changes to that infrastructure should be repeatable and predictable. So imagine if you want to deploy prod, so you do a whole bunch of things, deploy production, then somebody asks you, hey, can you provision development for me, or a development environment, or a staging environment, or whatnot? Then you either have to have really good documentation, which not all of us do, or you have to kind of remember what you did, right? Imagine that, remembering stuff. No. So let's not do that. Let's write a piece of code that describes our infrastructure and use that piece of code as like a template, as a thing to launch our resources from, right? It also comes to the point that when you treat your infrastructure as code, you get to apply all the best practices of code or application development through infrastructure development. So no longer do you click and hope. You test, you push to a pipeline, you validate, you version control, you keep your infrastructure in a Git repo to make sure you can roll back or understand what changes happen when. And again, the last point on this little slide is that you can replicate your production and staging in all the environments, quite easily, right? And I'll actually show you this later on. Now, why CDK? So why am I talking about CDK? There's a bunch of tools out there, and I'm not going to compare them. But, Marcia mentioned CloudFormation, and there's a serverless framework, and there's always SAM, and there's Terraform, there's a whole lot of different things. But let's say you hate JSON, right? JSON is nice, but it's for robots. YAML is great, but those tab spaces can be a problem. But let's say you just want to do a bit more than just a templating engine. Let's say you want to do maybe some logic within your template. You want to do some conditional, some looping, some reading off a disk, right? Well, this is where AWS CDK, or Cloud Development Kit, comes in. So a cloud development kit is this multi-language development framework. In essence, it gives you the ability to run general purpose programming languages such as Python, JavaScript, TypeScript, Java, C Sharp, and F Sharp is, I believe, supported right now, to do the same, right? So you could have kind of do this through the process of using an SDK for any of these languages. But the problem with that's not through infrastructure as code, because it's an imperative way of doing it. This is a declarative way of doing it. For example, you describe a VPC or a Lambda function or an API gateway or a DynamoDB table how you wish it to look. Then you just pass it on to CloudFormation, to CDK. Then CDK does some magic and creates CloudFormation, and then CloudFormation provisions your resources. At the same time, you can keep on using all the best practices or all the tools and utilities at hand with any of these programming languages here to help you do some fancy things. For example, a typical thing would be, this is a more traditional approach, but when you use an EC2 instance, you would pass some user data onto it. Like it would be a shell script or a PowerShell script. In CloudFormation, you would have to keep this in the same, single text file. You have to do a lot of escapes. It's horrible, right? But with CDK, you can just read a file of disk, right? You can keep a shell script on disk, and when creating a virtual machine or EC2 instance, you can just create it from there. Amazing, right? So how does it all work, from like a kind of more of a high level perspective? So you create this thing called constructs, right? The constructs are apps, stacks, and resources, right? So these are the actual things you code, the meat and potatoes of everything. It gets taken over by the CDK CLI. So the CDK CLI is your main point of contact, right? So this tool takes your CDK code, synthesizes or converts it to CloudFormation, and gives it to CloudFormation as a change set to actually deploy your code. So this is, again, still relying on CloudFormation in the backend, but that's a good thing in this case. So a couple of main concepts here. I'm just going to kind of skim over these things because you should understand the main concepts of CDK in order to kind of follow me through this. You have a core framework, which is an app, a stack, and a resource. An app is this whole overarching thing, a thing that has a purpose, right? Stacks are multiple CloudFormation stacks, multiple regions, multiple environments, multiple whatevers, right? Within the app, and those stacks contain resources, and resources are, AWS resources, right? So your Lambda functions, your DynamoDB tables, your whatevers, right? Whatever you would create on AWS through, anything, you can create here through CDK. There's also a construct library. So this is kind of a predefined way of launching certain things. And for example, if you ever created a VPC in CloudFormation, you would recall that it takes like 75 lines of code to create a VPC, right? With a construct library from CDK, it takes one line to create a VPC. Amazing, right? And there's also like predefined construct libraries. For example, let's say you want to launch a Fargate service, right, running on ECS with a load balancer. You can literally just use 5 lines of code to use a predetermined construct or a pattern to use from a library to deploy something much more. So that's pretty cool. And finally, the CLI is the tool we'll be using for most of these things. So just to go a bit through the constructs, right? There's a few different ways of doing constructs. There's a CloudFormation way. There's AWS services or the CDK way of doing these things. And there's the design patterns. The design patterns are these big things like this Fargate service that you see here. This little snippet of code, that's 1, 2, 3, 4, 5 lines of code. This creates a whole load balanced Fargate service for you, right? There's a whole bunch of other examples. I just use this because I know it works. So, for example, these 5 lines of code will change 817 lines, or basically it will generate 817 lines of CloudFormation templates for you, right? So pretty interesting, right? A lot of the things can be done through CDK, but most people don't spend time there. Most people spend actually time in like CloudFormation resources or service constructs, or basically CDK constructs themselves. Let me just show you how they look in a screenshot form. Then we'll switch to the actual console. So this is how a CloudFormation resource would look. So in this case, I'm just creating a VPC through CDK using the CloudFormation resource. And this is like a very unopinionated way. So you give it this, it creates just a CloudFormation, a VPC. So it creates literally just a single VPC, nothing else into it. So if you're using CloudFormation resource construct, this is how it's done. But if you're using the standard, right, CDK constructs, and you do the same thing, it does much more. It creates like elastic IPs for NAT gateways. It creates internet gateways. It has a whole lot of things because it has predetermined some things to use them, right? And finally, the patterns, the thing I mentioned before with the Fargate thing, this Fargate pattern or the application load balance Fargate service pattern will basically create a whole lot of things from ECS services, load balancers, like as 817 lines of CloudFormation code. That's all fine and dandy, right? But let's have actually look at some code. So my goal for today is to just kind of give you a quick rundown what CDK is and how does it look. And then I'm going to switch over to my terminal. And then we're going to build a serverless application through CDK, right? From scratch. So let's look at some code. Oh yeah, also this code will be available on my GitHub page, which I'm going to show you a bit later on. So let me just end my show here and switch over my screen share to something else. And this, voila. So welcome to my terminal. So what are we going to try to do? I'm going to create a super simple serverless application that is just having a bunch of Lambda scripts, a DynamoDB table, and an API gateway. I'm not going to go into all of this EventBridge magic and maybe not even step functions. None of that Marcia described because I didn't have time to do that. So, but yeah. Also, I have my eye on the Slack channel. Simon asks, do you think we should use CDK with TypeScript if you could only choose one? So I chose TypeScript because it had the most examples initially, right? So now you can see a lot more languages have the same examples. It doesn't really matter which one you choose. They're all open source, they're all available, and all of them will be kind of used to an extent, right? So the one you're most comfortable with, you should use, right? I found TypeScript to be the simplest one to use because there was a lot of examples initially. But if you're a Python person, there's a Python one. If you're an F person or C#, just go for it, right? Do I have resources about CDK when you can learn best practices on code organization for CDK? So I would suggest that you check out the CDK workshop. It has like a great getting started workshop on how you do it. And when it comes to code organization, it basically boils down to the same thing like any application. You can create libraries, you can kind of plug in those things into your major application. So you don't want to keep all the things in the same file like this person is going to do today. But you might want to separate out those things on kind of more logical things. Okay, so let's start. I'll create a directory called Nordic CDK. Right? So I'm going to change the directory like that. I'm going to just run CDK init. I'm going to give it app as a app is basically defining like a template. If you don't use anything, it will use app by default. There's also library and a sample app. And also, I need to define a language. Language equals TypeScript. And wabam. So it will create the whole scaffold that you need for your application right now. So with all some basic files and things you need to get started with. By the way, I'm not going to be coding all of this from the get-go because I have a lot of copy and pasting to do. You don't want to look at me code 100 lines of code. Also, I'm not an expert in TypeScript. So any TypeScript questions, please, maybe we can take them later on. Zephyr asked me, what do you think? Is it possible to have only one team for business requirement development and deployment with something like CDK? Will that be possible? For business requirement development, in what sense do you mean business requirement development? Is that something like, maybe you can elaborate a bit more on that, Zephyr, and I'll have a look on your question as well. Okay, so we have created an application right now. So if we look here, there's a whole bunch of things, right? There's a lot of code. There's the CDK.json, there's the bin, there's the lib, there's the also lovingly node modules, right? There's also some testing things as well. But the first place we need to start in is we need to actually initialize our stack, right? To create a stack. You remember me creating those constructs, app, stack, and resource. So we have created an app right now. Let's look at the stack. And the stack file is actually contained in the bin directory. So I'm going to open that with bin. So this is in the bin slash application name.ts. I hope my screen is large enough. I hope people can see this okay. I hope it's not too tiny. So in this case, if I wouldn't change anything here, this would just work, right? Basically what it does, it initiates an application called CDK app, but it also initiates a stack called Nordic CDK stack. So in any, let's say, production grade application or infrastructure, you would have multiple stacks. It wouldn't be a single stack. You would have, a simple example, you have a production and a development stack in this case. So I have in my thing here something else. Oh, wait. Let me do something. I wanna take a step back because I did my sample application in a different name. So I want to change it so I don't have to update my variables. So mkdir, it's called Serverless CDK, right? And then CDK, Serverless CDK, and then CDK init app language TypeScript. So this will just repeat the same thing I did. By the way, all of this, like all the initial steps, are available on GitHub with all the code I'm going to be using. So you can just test it out yourself. Okay, so Zephyr, you're asking, is there always an application development team working on feature requirements by customers and DevOps team making care of deployments and SRE port? It's actually absolutely possible to combine them in a singular, because here's the thing. When you use serverless, especially, you're trying to be agile in the cloud and all the best DevOps practices, you kind of run into this, you run it, you own it. So the people who are actually creating the application are also have the ability to create the infrastructure, right? So it doesn't take a lot of infrastructure knowledge to deploy infrastructure like that. So your developers, your application developer, your business requirement developers can basically use CDK and deploy things with it as well. So if they want to deploy the microservice that does X, CDK in it and just deploy it, right? So this is kind of where it all blends together. Usually what we see is people owning a single project through and through, right? There's no thing like a DevOps engineer, right? That's a mystery animal, and a developer. So it's all kind of the same person. Okay, so back here, bin serverless CDK TS. Okay, so let me just copy paste a whole bunch of things here. I'm gonna do like that and that, and I guess stacks and that and that. So I pasted a bunch of things here. So the difference right now is I have created two stacks. I have a stack called prod, and I have a stack called staging. So this, in essence, gives CDK the ability to create two types of a stack, or two stacks. And with these stacks, I pass them specific variables. In this case, like, is it production, true or false? And maybe a region in this case. So this is all I need for my stack. And this is one of the best practices you should start using if you want to use a CDK in production. So in essence, I'm done with this. I don't have to care about stacks. This should be it. Now let's go to the what my colleague Americans would say, the meat and potatoes of my application. So vim lib, and there's the serverless CDK stack.ts file. This is where your code goes, right? So this is where the code that defines your stack, and I say stack because it's a singular, and based off this code, we can change what stack is launched, right? So remember staging and prod. So first of all, I just want to add something here, because we have defined properties before, like, is it prod or not? So one of the things you have to do here is, well, you need to do, I need to set paste. Okay, cool. So I have just created an interface for properties for my stack. So just basically for the prod, for the prod variable. Okay, now one of the things that when it comes to CDK, because it uses these modules right from npm, we have to install a whole bunch of modules for our application. So to get a list of those modules, I actually have them on my GitHub page. I'm just going to paste them here because why not? And I'm going to save this, and I'm going to do maybe that. And I'm just going to paste, I need my fish shell, I'm just going to do that. So this will install the Lambda module, the API Gateway module, and the DynamoDB module. So all this is going through, and hopefully it succeeds. Okay, awesome. Come on. We're at the API gateway part. I maybe could have used them on the same line, but hey, never thought I was good. Never said I was good. Also, make sure if you create this in a Git repo, by default it will do some Git ignores, but do not include the node modules directory because you don't want that on your Git server. So, yeah, we have created this right now, so I can exit this, exit like that. So we have our module. So we have the core module imported here, but I want to add more of them, right? So there you go. So I've added my import Lambda, API Gateway, and DynamoDB. So how does one create the DynamoDB table here? Well, one of the things we can do here is create a constant called table. So let's do it. This is the only thing I'm going to be typing all day, so don't worry, I'm not going to be doing this for all resources. So const table new dynamodb.table. Also, if you use some editor like VS Code or something more advanced, you have all the hinting there as well. So I'm just used to them. So this, and I'll call the table people. Now this name is just a logical representation of this table. It's not something that I have to worry about in the long run. So I'm create a table here, and I'm going to just do the partition key name. I'm just going to use a name as the type, the partition key, and the type will be DynamoDB string, basically. This table name. Now, I need to give this table a name. Here's one thing I also would like to point out. So remember, we have created two versions of a stack, a prod and a staging stack. So one of the things we can do here is, depending on the value of this parameter here, we want to do some logic, or we want to do some things with our resources. So let's say we're launching a staging table here, or staging stack. We want to give it the table a different name. So one of the things we can do here is basically we can do some if-else logic on if do we have a production or a staging environment here. So if I do that, so I just pasted a whole bunch of code. So that this looks. Sorry for my terrible pacing. Come on, yes, thank you. Zephyr asks, how can we achieve something similar to reusability of code in the form of constructs? So you can create libraries. So one of the things, this file is actually a library. And this library can be reused anywhere. So in this case, I have created a full-blown application with built-in libraries, but you can only create libraries. And then basically, if you do something like this, Ben, and then serverless, sorry. So edit, Ben. Basically, you import a stack here like that, right? So you can import different libraries here as objects, basically, and use them in anything. So you can have this reusability of code across the board. Okay, so if you have a look at this code block here, right? So this code block is basically, as a look, do I have the property production defined? And if it is prod, if it is true, I will set some production parameters. I will set the concurrency to something higher. I will set different Lambda variables. I will give the production table or the production table a different name. API gateway, we get also a different name, etc., right? So these things are defined right now. So depending on which stack I launch, I will use these parameters. So let me just go here and choose table name. Right? There we go. So one of the other things I need to add here for the table is I need to set up a read capacity, right? read capacity, and I will use the dynamo db read write parameter, or the variable which I've created upstairs before. And finally, billing mode, right? I will use the DynamoDB billing mode for provisioned, right? Because I have a defined provisioned concurrency or the read write capacity actually. So DynamoDB billing mode. Awesome. So in essence, what this will do, this will create a table. So now if I would run this, it would create a DynamoDB table in my account. Let me just do something here. I want to do Nordics. I want to change these things because I may have something like this already running, right? So, okay. Okay. Cool. So, in essence, now if I would just exit out of here, and I have not tested this with a single line of code, but let's try it. So if I would do npm run build, so there's one reason why you need to do npm run build. In this case, it's because this is using TypeScript and you need to build it into JavaScript. So if you would do this, it would hopefully build it into JavaScript. Let's see, does this work? No, I have failed something. Property prod does not exist on type something. What did I do? Welcome to live coding, folks. I have not done something here. CDK stack props. Have a look. Interface extends CDK stack props. Let me edit the bin file and then this one. Please, that and that. CDK stack. This looks all pretty okay. I don't see a reason why this wouldn't work. Serverless stack prod. This all looks pretty standard. So luckily, because I was afraid this would happen, I already have an application ready for us. So you've seen me do some basic things, but let's actually go to something proper. Let's go to repos, or actually go to workspaces, repos, and there's an application called AWS CDK for serverless. So this is the full-on serverless application that basically I've created for this. So if you have a look at lib serverless, and there's this TS file. So this is the file I have been working on. So here, what we have right now is we have these properties defined here, depending on is this prod or not. Then we have a DynamoDB table here that basically creates a DynamoDB table depending on some of the properties we have set. We define an API gateway. So you want an API gateway? This is how you create an API gateway. A single line of code. Love that. We have one Lambda script here. So here's a Lambda script that just says hello. This is how we do like Lambda integration. So this is where you do Lambda integration with API gateways. So this is how you would create I create basically a resource called hello on API gateway. With the get method, I get this Lambda triggered. A new Lambda, this is a user input Lambda. So this is just a Lambda function that creates the user in the DynamoDB table. Simple as that. So you define like your runtime here, you define your code. Now, the code gets from assets. An asset is a directory, in this case called Lambda, where my Lambda functions sit in their raw format. I basically have JS files there that sit, and this takes the code from that Lambda directory, and depending on the handler is create user, it will take that handler and basically create that file called createuser.js and use that for the Lambda function. Again, integration. Now, here's one thing that CDK has a great feeling. The table permissions. So as I created my Lambda function, instead of going about and creating this IAM policy or role or whatnot that grants my Lambda function permission for this table, I can just use this one single line of code saying, hey, remember that table from upstairs? Grant read-write permission to this Lambda function. Simple as that. And the exact same thing I did for another Lambda function here called user read Lambda. Basically, this is the same thing, but it just reads your user from a table. So, you remember this, I created 2 stacks. So if you go back here and look at my TS file here, you see that I have a prod stack called prod and staging, right? If I would do CDK-LS would show me 2 stacks. Now this error, I don't know why it's happening. It started happening today, so that's fine. CDK-LS shows me that I have 2 stacks available for deployment. So if I want to deploy something, actually I have CDK destroy staging. I have a stack already in production or in staging that I just wanted to show you how you. Actually, let's do this. So let's deploy production, right? CDK deploy, or one of the things you can do. There's 2 commands how we run CDK. There's CDK deploy, which handles everything. So it takes your code, creates CloudFormation from it, creates a change set, and basically deploys your application. There's also CDK synth. If I run CDK synth and production, or prod, it will synthesize my CDK into CloudFormation, right? So you get this big old CloudFormation file, which is very complex, right? So there's a whole lot of different things. It does all of these things for you. So I so much lines of code. So you can do that, and there's a lot of people who actually use CDK synth to synthesize CloudFormation code and then use that CloudFormation code and manually deploy it, or with some other pipeline. By the way, I have another question from Mr. Zephyr. As you explained about reusability, does it mean if we have some count of lambdas with the same properties as some different respective to each lambda, I can achieve this once construct for properties of lambdas? So when I talk about construct in this case, I'm talking about like having a library that does something, like create a bunch of lambdas, create something. So it's not creating like a custom lambda function. So you can have those lambda functions sitting in there as well, right? So you define lambdas from an asset directory. So in this case, I have a lambda directory here. If you see, there's LL lambda, right? So, and I have my lambda functions here, but your asset directory can be somewhere else as well. So it doesn't have to be in here exactly. And the second question about prod, QA, and dev deployments and achieve some similar blue-green deployment. Do you have to take care of it in CDK, and can it be automated? So absolutely can be automated. It's not available from the CLI itself, but if you use a pipeline tool such as GitLab, CI, or Jenkins, or Code Pipeline, or whatever, you can do all of those things. You can basically deploy your code with CDK through all of this different staging of development. And Jojo asked me, how can one test CDK code, unit testing, or integration testing? Oh boy, you missed my talk. I had a talk last week on CDK testing on the Nordics Dev Day for AWS. I'm gonna send you a link on some information on that later on when I switch away from being live. But let me go back. Let me deploy something now. So let's actually deploy a production environment. So CDK deploy prod. Now what will happen? CDK is synthesizing my CloudFormation thing, and it also generates a whole bunch of things. If you do here, go that and that, you will see that it shows me what it will create, right? And in this case, it will show me what IAM changes, what permission changes will it make. So I'm just aware what this will be created, right, from security. So do you wish to deploy changes? Absolutely, I do. Click yes, or please click yes, and it's deploying. So what's happening right now is it's basically publishing some Lambda scripts to an S3 bucket. It's creating a CloudFormation change set, and it will show you all of those things, right? It will basically create, and you will see all the CloudFormation output here as well. Zephyr says, I attended that talk halfway. Oh, thank you very much. I really do enjoy giving that talk again. By the way, there will be a repeat of the same thing coming up in an upcoming Dev Day sometime soon. So be on the lookout. Okay, so it's creating a CloudFormation change set, and let me actually switch to something else here. I want to switch to my share screen. I want to share a different screen. I want to do that. So now you're looking at my my AWS console, which is too large. If I go to CloudFormation, you will see, hopefully, this being successful. Maybe, come on. It's the afternoon, and the internet in Germany in the evenings gets a bit bad. See? There we go. Stacks. If I go here, you will see prod, create in progress. And on the event side of this thing, you can see that it's creating basically all the different kinds of things. So from, handlers, Lambda scripts, you will see all of these things being created as we speak. Can I do refresh? So like Lambda functions, policies, roles, API gateways, and a whole lot of different things are being created right now through this. And if we go to actually to like Lambda, we can see that we have prod, prod hello, prod create, and prod read created here. I have the staging ones as well because I've created them before, and they're all created here through CloudFormation, or well, through CDK and CloudFormation. Going back to my console again, like so. Now what you can see here is that one of the outputs I have, once this is finished, you can see this little check mark, it says okay. And the output is basically an API endpoint. So I have this big old API endpoint here that's serving my serverless application here. So if I would do something like curl and then like that, and then do hello, and I should get hello and welcome to our serverless application. So this is that first Lambda function I created, and it's just a hello. It just spits out hello. And if you want to have a look at this, it's in Lambda and hello. It's just a hello world thing saying hello and welcome to the serverless application. But if I want to do something more, so I need to copy paste something here because I have a long curl command here. So give me a moment. Let me do this. Cool. So I'm making a curl command right now that's gonna basically post to my endpoint with a whole bunch of things. I'm creating a user. I'm passing a name, a location, and an age. And when I do this, it should hopefully, no errors. So now what has happened, it has actually created a user using my Lambda function. If I now go here and change this to this, sorry, like that. Now I do another curl command that basically takes, it uses the read function that I created before and just passes it on the parameter Darko. And hopefully now, that doesn't matter. Now I get the output name, Darko, location, Berlin, age 32. And that's it. So in essence, this I have us deployed very simple 3 Lambda script, 1 DynamoDB table, and 1 API gateway Lambda application or a serverless application in the cloud with this repository. So CDK has enabled me to do this. Now, I know I did a lot of copy pasting here, but in essence, it would take you maybe a couple of hours to figure all of this out and create your serverless application. And once you're done with it, the best command in the world, CDK, not deploy, destroy prod, right? If you do this, what this does is it actually just deletes everything, right? The only thing it doesn't delete is DynamoDB tables, which you have to do manually. But it basically destroys all the resources. I have prod running right now. I can also destroy staging as well. So because I have staging running here as well. So if I would switch over to here and like, for example, go to workspace, repos, CDK for serverless, and then serverless like that. And I can do CDK destroy staging. It should also destroy staging for me. So it's currently deleting the production one. If I go back here, it's going to, destroy staging, please, goodbye. So that would be basically my demo of this, and I hopefully showed a lot of things. I like to show my console, and if you're interested in a very beginner approach for this, I'll share the link of the a workshop you can run it. So it's an online workshop, free, whatever, right? And it does it in Python and TypeScript, I believe, and also I think there's a .NET version of it as well, and you can try it out for yourself. So let me also switch back to my slides because I want to just self promote a bit, right? Going back to this screen share and that. Coolio. So you saw my code. How to get my code? Here's the QR code. If you don't have a phone with you or you don't want to take a photo of your screen, search for my name on GitHub. There's a CDK repository that you can look at. It's AWS-CDK-4-serverless or something like that. You can check it out, and I'll also paste it in Slack as well. So. I think I've answered all the Slack questions directly, but I will stay on Slack for a while as well. Thank you very much. Thank you all for inviting me here. Please feel free to contact me on social media and Twitch and whatever. If you want to see me do more of these things, I do these kind of streams, live coding, whatnot, live twice a week, and you will be probably seeing me on a lot of other events coming up in this year. So thank you very much.
All right. Thank you very much, Darko. Since you've already answered all the questions, there's really no questions left. But if you have any more questions, just ask them in Slack and Darko will answer them there. And with that, we've finished our 2 talks. I just want to plug Serverless Hero Yang Kui's 4-week course on building production-ready serverless websites. It's available now on homeschool.dev. Jan has also been kind enough to give us a special discount for Nordic Serverless. So using the code you see on the screen right now, you can get a 15% discount. So do check the course out. It's a great way to start building serverless using best practices. And EventBridge is part of the course as well. So our next meetup is already on Tuesday. We'll do a Nordic Serverless Observability Special where we'll have Epsagon, Thundra, Dashboard, and Lumigo, and they'll give a session each on serverless observability. And you'll get the chance to ask them questions on observability in general or about their specific services. So that's this Tuesday, the 21st. I also want to mention Serverless Days Virtual happening on April 29th. Like all serverless days, this is a great way to learn from some of the best people in serverless. And we in the organizing team, we are really happy with the speaker lineup for this event, the first edition. And the registration is open, so just join us. The event is free as well. And with that, I want to thank you all. Thanks to our speakers, Marcia and Darko. And thanks for all the questions in the Slack. And thanks everyone for attending. See you next time.